Hello everyone, welcome to the Geek Nighter podcast. I am your host Keval Yapte. Today I am joined by Megha Arora, who is a staff developer advocate at MongoDB. And today we are going to talk about how do we make some decisions related to databases and driving those decisions using customer use case, and how do we keep customers use case at the center and drive those decisions. So, welcome Megha to the podcast. I'm really excited to have you. Let's start with a brief introduction for our audience.
Hi, Kevalia. Thank you for having me on your podcast. And I have around 11.5 years of experience in the industry. I've played different roles in different domains of different capacities. Prior to joining this dev advocacy role, which is a relatively new thing. Coming into Indian market. I
Hmm.
was part of companies such as Microsoft and Apple, and my last position at Apple was kind of a SD4 or tech lead. And this dev advocacy just happened to me, and I am still figuring out what to do and what not to do in this role. And one thing I would like to highlight: this is not a non-technical role, but it is a techno-functional role.
Yeah, makes sense. Makes sense. Thanks for clarifying that. Because I think since it's a new role, there's a like a lack of clarity and what is required and what is not required. But
Right.
at the end, it's all technical because you deal with developers, you deal with technology, so it's all in the tech space. So great. Let's define what we are going to talk about. So the agenda for today is we are going to start with what customer centricity means, what are the use cases, and how do we use that to drive decisions in choosing a particular type of databases, right? And we are going to also talk about what kind of databases are available, and we are going to share some experiences based on you know uh, our system design experience where we have designed some applications keeping customers in at the center, and how do we make those decisions and what kind of trade-offs do we make, and at how deep a developer needs to go to understand a database. So we are going to talk about basically, do we know our databases well? Let's start with uh, so Megha, I want to ask you, like, why is it important to keep the customers at the center?
Right. I think when we were talking, I already mentioned this one example which I give to my students or anyone whom I'm talking to. It's very important to understand the domain. The domain could be a customer driven or a tech driven domain. But for now,
Yeah.
most of the examples we see are customer driven because you just think about it and you can do it online. Like you can go online to order your food, to get a cab, to get anything you want to like Amazon and Flipkart. So it's just that if I talk about two contrasting domains, I'll not say on the basis of cap theorem or consistency or availability. It's just that on the basis of the use case. If you talk about banking domain, for example, you get that message that okay, hey, your the site is under maintenance and you have to wait. So you don't go to the bank that day or the next day or the day before, day after that, or that week to shift your money from that bank to another bank. But if the e-commerce site is down, you don't even wait a few minutes, you just switch your e-commerce site. So that is how domain is important, customer is important, driving your tech, your work life, whatever, I mean everything is associated to that. So
Makes sense.
that is what I mention to anyone I'm talking about. And when I teach system design, I definitely give a lot of weightage to domain, because
Yeah.
there are a few people who would, let's say we are doing designing a search engine, so there are a few people who would come, should I directly say map reduce? How did you reach there? It's just like your data structures and algorithms or problem solving. How did you reach to the map reduce? Did you actually
Yeah.
had that kind of problem at hand, or you just are putting something which is not even required? So adding complexity to the system or adding more components to the system is again domain dependent, problem dependent. So that is one thing which I really want, I mean, all of the audience to understand and remember.
That makes a lot of sense. I mean, unlike like traditional applications that we had, uh, nowadays customers have a lot of options. They have, you know, so many applications to do the same thing, and you need to be really customer centric and solve
Right.
their problem in a way that, you know, that is better than others, that is better than your competitors. And unless you do that,
Right.
you're out of the game, right? So that is a very important thing to understand. And I've also seen, when I take some interviews around system design, there's a lot of, you know, technology knowledge, but there is lack of understanding of customer needs, lack of understanding of the user experience, the user of the product, right? And I think things, when we start thinking from that perspective and make those incremental decisions, I think things get easier. We don't have to solve the problems
Right.
that are not there. And sometimes people just spend time solving the problems that are non-existent. So I think that's a great thing to do. So always start with the customer and make those decisions based on that. Great. So when it comes to, you know, databases, right? Let's first define what do we mean by a
Okay.
database.
I think something to store my data and to make it easily queryable. I can store my data in a file system as well, but then I want to
Yeah.
query it easily and faster, because I want to promise a SLA, or have low
Hmm.
latency. Obviously, as we are talking, we have a lot of competition in all the domains, and we cannot lose our customer to a competitor. So that is why something we can do is, like, we can do a lot of online processing, and in that, even if we are doing some offline processing, maybe we lose on a little bit of consistency, but we still promise like faster response to the customer, at least. I mean,
Hmm.
even if the there is some issue with the system, or there should be complete fault tolerance in the system, so that we do graceful exits, so that customer is not hanging in the air, that, oh my god, what happened, where is my customer. Yeah,
Yeah.
these kind of
Yeah.
things definitely. So
Yeah.
database is something wherein I can store, then query easily if I'm writing that in points, and then query faster. And then if I want to change something, zero downtime. If I want to change something, if I want to migrate it to some other
Yeah.
let's say we are scaling or doing some other thing, again, some kind of zero downtime for that as well. So these are the points I can think about. Anything else you want to add?
Yeah, I mean, when we talk about databases, right? So there are different ways to look at it, is what I think. So from the customer's point of view, they don't care what kind of databases do you use, right? They just want their data to be secure. They want some guarantees. So if they are
Right.
storing, let's say you own a file system, if they are storing their files, some images, they want their images to be there no matter what. They want their access to be, you know, secure to the
Right.
file. From the developer's point of view, right? uh, Database is something, it's best if they don't have to think about any of the operational stuff about the database. But nowadays it is changing, right? So in traditional
Right.
environment, there was like traditional rdbms systems. There used to be database admins, and developers used to say, okay, I'm going to write this query, and it is your job to make sure that it works.
Mm,
Right indexes are at place. But that has changed,
mhm,
right? Because we have so many
mhm.
options now, and the developer is the admin of any database. So yes, database needs to store
Right.
data in an optimized manner, because we don't have unlimited money, unfortunately. We It needs to optimize around storage, it needs to optimize
Yes.
around queries, and it needs to make those right trade-offs, right? Because
Yes.
no database is perfect. That's why we have so many databases. Otherwise,
Mhm.
if there was a perfect database, we wouldn't have, you know, so many options. So as you rightly said, there are different parts to it, and no part is solved perfectly by any single database. And that is why it is important to understand what do we mean by a
Mhm.
database. So I think I would just add the, you know, the cost part of it.
Right.
And apart from that, I think you have rightly included, uh, so it should be fast, uh, but, you know, it should also be cost effective. um, Great. That makes a
Cost.
lot of sense. Now let's talk about taking like a customer use case and converting those use cases to making a right choice for the database, right? How that journey would look like.
So let's say if we have uh, a customer use case wherein, first of all, I think we need to think in a monolith fashion. What kind of data do we have? What kind of customer we have?
Yeah.
And then so basically, what all we said till now was like we need the database to support, help build applications faster in a cheaper and optimized way without losing on customer data and privacy. That is what is how I look at it now after
Yeah,
having that discussion with you. So if we have a
makes
use case,
sense.
so we need to figure out like what are my the most go to requirements, and according to that come to the type of
Mm,
storage I would want to use. So definitely cost effectiveness, not losing on data privacy, and making the storage persistent, like giving that kind of guarantee by using some kind of replication are the three factors. Zero downtime, and that is like for dev ease, that can come in a little later as well. So I would
yeah,
definitely look out for options which is giving me a guarantee that okay, my data will stay wherever it was stored, so that's some kind of replication. Then if it is cost effective and cheap, so and I will also think about what kind of data I have to store and what is the scale I will be storing at. So so these 2 points
hmm,
are quite important, that what is the scale and what is the scale five
yeah,
years down the line I'll be looking at. So these two things plus the type of data.
makes
I
sense.
will not say structured unstructured because I really don't like that paradigm, because even when I talk about NoSQL, NoSQL is good enough to store even structured or semi-structured data. So I don't like that one. But yes, if your schema is going to change very frequently or you don't have it figured it out yet, so NoSQL is something which you can go. Like if SQL and NoSQL, I know it's little easier to scale NoSQL, but it does not mean that it is not SQL is not scalable, because a lot of commerce still runs on SQL,
Yeah,
including Facebook and Uber. So that is where I only see
exactly.
one key differentiating factor or decision maker is if your schema is going to change very frequently, or you haven't yet figured out like what kind of information my system would have or my DB would have. So that is the key differentiator on NoSQL and SQL. And then NoSQL different solutions, but then there's a lot of confusion. Even few key value can be even I mean, there is no need of graph database. Sometimes you can just use key value to store graph kind of relationships as well, by doing some kind of vertical sharding. So I've seen such solutions also. It definitely depends
Hmm.
on the team. Like it's not one person. It's like a incremental discussion which would happen time and again, and then people will keep on designing the DB. When I have worked on with applications from scratch, so what we did is we hard coded some bunch of data, and we made the app, and then we made the API with some hard coded data, and meanwhile some of us were talking of the DB thing, because it takes a little more time to do
Hmm.
the data modeling to actually design. Even if it's NoSQL, it does not mean that schema will be easier, or data modeling will be easier. There's a sweet spot. You were talking about
Yeah,
trade-off, so thinking about the partitioning and thinking about the keys is very very important, because you cannot dump everything to the same collection. So that is also one challenge we have
yeah,
faced, and these are the things I think we can take care of. But as I said, it depends on what kind of team, what kind of domain, and what kind of scale you are looking at, and what kind of absolutely resources you have at hand. Yeah.
absolutely. Yeah, I think you shared some of the great points here, and that makes a lot of sense because those are the things that drive your decision, because ultimately you have to make some decisions based on the input you have, right? And those inputs can be your customer use cases, what kind of developers you have, what kind of company you're working at, what kind of options you have, and how much time you have to build that application, right? So another point you made was that people assume because SQL databases or traditional SQL databases are so old, they assume
Mhm.
that they are not scalable, they are not meant
Yeah.
for high scale applications, which is not entirely true. I mean, unless you so not everyone is Google, not everyone is Facebook, right? And people need to know their scale, and they will know their scale if they know their customers better
Right.
and their use cases, right? um, and as you gave two examples, one was the banking application, other one was a social media or an e-commerce, right? So e-commerce definitely
Mhm.
has more scale, but we cannot just have
Yeah.
one bucket for e-commerce, because e-commerce
Like.
has tons of things. It has search, it has product inventory, it has order processing, it has cart application. So it's not like e-commerce has huge scale, because some of the use cases like order processing might not be as high
I
scale as
definitely.
search.
Yeah.
So again, one domain can also be divided into
Right.
several
Right.
parts, several systems, and that's why it's not it's not necessary for us to stick to one
Absolutely.
database. We can
Polyglot
also
designs.
decide
Yeah. That
multiple
is why
databases.
polyglot
And
came into picture.
exactly,
Microservices came into pictures to have like different scales. And polyglot is one thing which
exactly,
I mean, we readily see polyglot that we
exactly.
frequently see.
And I think microservices, yeah, I think microservices architecture has kind of made
Mhm.
it easier to think
Mhm.
about polyglot persistence, right? Because a search service can use, let's say, in a
Yeah.
elastic search at the back, and an order processing system can use like a
Right.
MySQL or a Postgres, because relational
More
model might
sense.
make
Yeah.
more sense for that. Uh, so yes, like keeping the customer use case and what problem we are
Mhm.
trying to solve, deriving the scale parameters based on that, and what kind of
Discipline.
guarantees you want to
Yeah.
provide to the customer. I think that's if am I missing something, or I think these are some ways we can derive up
Definitely.
to a solution.
So what you added to what I said is like you talked about the timeline, and then you also talked about something which is like
Hmm.
you can divide the domain into different sub problems, or microservices or some kind of things which will be
Yeah,
like done in a batch processing or at the back end, so which will not affect the user, so it will be
yeah.
pre-computed. So that kind of things
Hmm.
also I mean takes a lot of weightage. And timelines, which I totally missed, it was like yes, it takes a lot of weightage too. And one thing you said, like some of the sometimes
Yeah,
which company we work at, yes, because the tech stack is already defined for us, so we cannot go beyond that. That is also one of the points.
exactly,
And one thing you said, like
exactly.
sometimes okay, in the order processing a relational DB might work better for the user, because we are we have been reading SQL since so long, so we are brought up in that way that okay, think SQL, think relational. But maybe it's not that it's not like it's not a sacrosanct okay, for relational data you go for SQL only. There could be a change in the way we
Yeah,
think in the upcoming years. Not advocating anything here, but
absolutely.
that is also there. The kind of developers, the kind of team we have, not only the company where we are working, the kind of wavelength or
Hmm.
thinking the team has. So since we have been reading
Yeah,
SQL, I think I had that as a subject in my college. Even I remember something from my school as well. So we have been thinking relational
yeah,
since a very long time, so that could be also one of the key factors that we think that way. And
yeah.
polyglot solutions definitely will come up, because we have different problems to solve. See, you are talking about breadth oriented, so there could be depth oriented services wherein only one problem is to be solved, like a search engine, or let's say we are
Hmm.
dealing with connections over a social media, so how to get the second degree or first degree connection. So that again is a sub
Yeah.
problem, and that is like a depth oriented problem. But if when we talk about social media or e-commerce, they are breadth oriented problems. So for example, if you have to order,
Hmm.
you have to list the items that is having a different data model, then you go into one single item that is having a different data model, that will be another service. And then when you actually add it to cart, that
Yeah.
will be a different data model and different service. And you place the and when you go to the payment gateway, that behaves totally differently. So these like 4 or 5 services in unison to do
Hmm.
just one task, which is like ordering. So these are the things like depth oriented and breadth oriented. We can definitely think about our services better on that. But yeah, to to start with any project from scratch, uh, we should definitely think monolith first. That is my 2 cents. Maybe you beg to
Yeah.
differ, but
Yeah.
first monolith, and then maybe we can think of SOA and microservices only when we are thinking, okay, we have to go polyglot, and only 1 or 2 services will talk to my data sources, this kind of data sources. Rest of them, like rest 1 or 2 will talk to this, and another 1 or 2 will talk to this. So that kind of bifurcation would actually lead me to the microservices paradigm. So
Yeah.
it definitely depends on a lot of factors.
I totally agree with that. And uh, I have many discussions with people around microservices, because microservices is kind of understood in a slightly incorrect manner. People took it as a silver bullet that, okay, monolith
Yes,
is
yes,
completely no, let's not do it, and
true.
microservices
Yes,
is the way
yes,
to go. But
yes,
especially for startups, they don't have such maturity in the organization, that they
right.
have toolings, they have automation. I think it's best to start with a simple monolithic application,
Yes,
because
yes.
at the end of the day, you want to solve the customer's problem in a
Mhm.
fast manner, right? You don't want to wait like 10 months just to release a simple
Yes.
feature, because you were stuck
Yeah.
in solving some of the
Mhm.
microservices problem, which you didn't have to
Right,
solve
right.
if you used monolith. So yes, it totally
Or,
depends on the org structure, at what maturity level you are, and what is the
mm,
developer strength that you have. So it's not like a interview, right? It's like a solving a real world problem, and there are so many other problems to think about. That in
mm,
interviews you can just say, okay, I'll use microservice and that, but practically it might not even be possible. So understanding
right,
that
right.
difference is important. So that's a great point. Thanks for putting up.
Yeah, Kevin. So if I am taking a system design interview, if someone directly comes and tells me, okay, I will do a microservice. So I ask them, why will you do? Okay, because the services, the separating the services makes more sense. Until unless
Hmm.
they tell me the reason, that it is like because I want to scale them differently. It is not even a different tech.
Yeah.
It is scale them with these services differently. I don't agree, I don't buy that. It's like, okay, just like a silver bullet, I know this
Hmm.
will be the answer. So that
Yeah,
does not
absolutely.
work in system design. So and I have actually seen wherein we started with monolith, we started doing a little bit of redundancy so that we can separate that out into microservices later when deployments will start becoming a problem. But until unless that happens, we can go and survive with a monolith. There's no problem with that.
Makes
And
sense.
yes, microservices comes with a own baggage of inter and intra team communications, having different life cycles of development, and then waiting for other teams to release, and you will release something and other teams will not have worked on that. I mean, they will not prioritize that. Something or the other will happen. So I have seen those
Makes
problems as well. So yes,
Yeah, makes total sense. So microservices might be solving 10 problems, but they bring in 1,000 more problems. So that's something to
yes,
keep in mind.
correct.
So yes, I think, and it applies to databases as well. So starting with a simple monolithic databases, which is, let's say, a MySQL single node cluster, or not a
Hmm.
single node database, that makes
Yeah,
sense, and it might solve most of your problems, right, in a very nice way. You don't need any other
right.
technology, because it is such a battle tested system. It supports
Hmm.
SQL. It application development is so easier with a relational model, because so many tools are available. Like there are so many ORM frameworks. Just you just have to write some code and you will have like your at least CRUD application ready within few minutes. So that is
You
so
have a
easy.
lot
And
of
then
framework, you have a lot of reference code out there. You have a lot of community support, so you don't
yeah,
have even have to worry when you're actually
absolutely,
spinning up a Java Spring Hibernate app. So it's very easy.
absolutely,
Absolutely.
absolutely.
But I had one more point. We were talking about if we want to do it very fast, and we were talking about monolith, but we
Yeah,
missed function as a service. We missed DB as a service. So these new paradigms, if you have that kind of resources and that kind of cost, then definitely these could be two new things to go to
yeah,
for
absolutely.
spinning up your new application. So this, just hit me. We talk about monolith, yes, for learning the actual development, learning the actual pain points. Monolith is the best. But then, if you really want to spin your app fast and you want to come up with that kind of scale, so something to look up. I'm not even talking about SaaS or PaaS. I'm talking about function as a service is too good,
Yeah.
or DB as a service is too good to even imagine. Okay, and I have just come across DB as a service, but prior to this, I've seen function as a service.
Hmm.
So wherein you just write. I mean, you basically think more on the business logic, and rest all is taken care of
Absolutely.
for you. You don't manage the infrastructure, so it's even better than SaaS and PaaS.
Yeah, yeah,
So
totally.
these kind of paradigms definitely people can look up, but again, the cost and the team which will take the decision or the company you work at
Yeah.
definitely matter.
And again,
Yeah.
to use something like that, you also need to understand the trade-offs that they are making, right? So there is always
Yes.
something that is hidden. There is always that asterisk mark, like terms and conditions apply, which means there are some
Correct.
trade-offs that you're always going to make, right? So nothing comes for free. At
Nothing comes.
least have some basic idea of what you're doing, and instead of making decisions randomly, drive those decisions based on customer use cases, your org structure, your deadlines, and all that, right? Let's move a little bit from this discussion to more on the database side, uh,
Yeah.
where let's let's talk about the options people have these days, right? So what kind of databases are available? So based on your experience, what types of databases you have seen like popularly used?
I have seen SQL as being the most adopted till date, and then we
Yeah,
have NoSQL. Two more popular flavors are document database, and then we have key value.
yeah.
And apart from this, we also have wide columnar graph, but I've seen more of document database and key value. But
Hmm.
wherever I've worked even now.
Yeah,
But yes, there are other special storage options which are quite popular, like Azure Blob, Amazon S3. Again, you call it for unstructured data, but it's not like you can't store audio or video or binary data in NoSQL. It's just
yeah,
that it becomes cumbersome. There is some limit. You will have to divide it further. But then S3, and so these special storages also are popularly being used, so that because it's like not that cumbersome, and then it depends on what kind of thing you are trying to solve and what will be the easy way out
yeah.
without having much of the developer capacity. I think the whole world is moving towards that, that
Hmm.
bifurcate the actual infrastructure problems or the actual technical problems from the customer logic, and focus more on the business logic or customer obsession. Roll out features which could help customers fast,
Yeah.
rather than actually focusing on the infrastructure or technical issues. So that is where we are heading at. So I think uh, we definitely look out for references. Most of us do. So we look out for, okay, this solution was done with this, and it fell into this paradigm, like whatever we have spoken till now, these paradigms. So whatever fits into that, and as you said, some kind of trade-offs will come with everything. Like for function as a service, it will not, like first call will be expensive and it will take a little more time than the other call.
Yeah.
So maybe your site would take a little longer time to load. So if that is okay with your domain or your customer, like first time it takes a little, if your customer is an educated customer, like it's like a few customer, it's an enterprise solution, then it's okay. But if your customer is, again, it's an e-commerce or something, so then you would have to look up for some solutions. And the solution should be easily solving, and it is like done, tried and tested. Or maybe you want to experiment on the basis of the problems you encounter, so something like
Yeah.
that.
Yeah, yeah, makes sense. I think the gist is that it boils down to the trade-offs you're trying to make based on the different solutions you have. As you said, like function as a service, it might have some cold start problem where the first call
Cool.
might be slow. Similarly, to
Right.
different types of databases, like key value databases, it's simplicity, right? It's so simple to
Yes.
just, it's a simple model. It's
Absolutely.
like a hash map. You just give a key, you get a value back. But then the trade off
Yeah.
is you can't really dig into the value because values are opaque. You can't really create secondary indexes on the values. And then you have slightly extension to that. Let's say you go on to document databases where there is a slightly more rich set of features where you can also
Mm-hmm.
create you have visibility into the value and you can create those indexes and you can also query based on the value. So it's not as simple
Right.
as key value, but it has a slightly
Right.
more set of features, right? And
Slightly
then
more.
on
Yes.
the other side of the spectrum, there is of course SQL, where you have all the features you want. You can use like beautiful SQL queries to get your data. Whatever type
Mm-hmm.
of query you want to run, you can create new indexes on different columns. So that all is there. Beautiful asset transaction or asset properties, but then scalability is a trade-off there, right? You cannot split that database. There are challenges. I mean, there are solutions available also splitting or sharding the SQL databases, but again there are
Yes.
challenges. So the more you
Right.
understand how your database works, what kind of
Mm-hmm.
trade-offs you have to make, whether it is scalability,
Right.
ease of use, or simplicity, or the storage cost, or the query
Mm-hmm.
patterns that are available. So query patterns is itself is a big deal, to be honest, right? So what I've seen, so customers on come to your website. If let's assume you have a website, they do a bunch of
Mm-hmm.
operations, right? And then these are the query patterns. Like how do you query your data? So storage is one part of it, and I think the easier part of it. But querying the data in a performant manner,
Manner.
such
Yes.
that it maintains your SLAs. That is the real challenge, right? And the query patterns
Right.
itself can drive those decisions. So I was talking to Patrick McFadden from Data Stacks about Apache Cassandra, and he has a lot of tech talks around data modeling. So he mentioned, like, in the previous or traditional SQL databases, they were trying to optimize for disk space because disk
Mm-hmm.
was costly, unlike today,
Yes.
right? And that's when they had this normalized forms, and you have to use joins. You can't store data redundantly and all that things,
Mm-hmm.
because you don't want to waste money on storing the same data multiple times. But that has completely
Right.
changed in, like, the
Now.
now, right? Let's say if we talk about Apache Cassandra, it is known to keep the data redundantly because it is trading off
Absolutely.
for scalability, higher availability, and all those things. But it loses the SQL joins, for example. So these are the trade-offs. So when we talk about Apache Cassandra or a NoSQL, I think the best is to
Mm-hmm.
start with the query patterns, like how customers are going to query your data. And then it
Right.
doesn't matter if you have to store that the same piece of data more number of times, but what matters is how that data will be presented to the customer and what problem you're trying to solve. These are the common databases that people tend to use. Like they go with SQL
Mm-hmm.
uh, until and unless they really want to try something new, or they are really high scale
Right.
applications where
Right.
they are not able
Right.
to scale rights, for example. And
Right.
then Cassandra, Dynamo is being popular. Of course, MongoDB is one of the most popular ones in document stores. And then for
Yes.
other use cases where you just want to store or dump data, as you mentioned, S3 is a big
Yes.
thing. Like a lot of
Right.
data, it's a low cost storage system. You just dump data, You get it there. You can run your Spark jobs or some analytics on top of it. So as we discussed, there are always trade-offs, and it's really important to understand those, right? Would you add something to that?
Yeah. Yeah, I was just going to add when I was trying to speak. I was just, when you were talking about query patterns and how views will drive the database, how so if you think about Paytm, it's a quite good example of how it is more natural to think in a NoSQL way, because if you need
Yeah.
to see the flights view, you just have the user data with the flights view. Then you need to see the movie bookings view, you do the user with the movie bookings or bills, same things. So these kind of views or this kind of query patterns, if the query patterns are very definitive, that okay, this is the kind of data or this is the kind of reporting my customer would come and see, so that there it's more natural to think NoSQL way or document store kind of way. Plus
Hmm.
as and you also said about that we try to go for the sequel until unless there's a huge problem to solve or we want to experiment with something, because we are we have been thinking sequel since a very long time. So that is one thing,
Yeah.
and that is why sequel comes more naturally to us. But if we go by the query patterns or we map the view to actual data storage, then NoSQL becomes more natural,
Yeah.
if you think
Makes
about it,
sense.
because the way I want it, I'm just keeping it that way. I'm not going to join anything. And as my disk storage is not that it's cheap now, it's not that expensive now, so
Yeah.
I can just keep my data redundant wherever it is there. So and
Absolutely.
I think earlier there were problems that okay, if you change the user data in something, so you have to basically manage it with the service, that okay, you have to change it in other collections as well. But now there are guarantees which are coming with NoSQL flavors. Plus there is a lot of work done on the encryption decryption. You were talking about something that values becoming opaque. So now I think with the new releases in NoSQL, I'll not name anything, but we can even query encrypted data, and we can get the sorted encrypted data as well. So that is also doable now
Yeah. Yeah. Yeah.
in the new releases. Yeah.
Absolutely. Yeah. I mean, these are great points, and uh, I think it again boils down to what problem you're trying to solve, because
Absolutely.
that will
What
drive
movie
your
is it?
decisions, right? And one
Yeah.
thing one thing I missed about Kafka, I think it is important because so Kafka started off as a distributed log structure, giving you those
Mm.
durability and high availability guarantees. uh, and but now Kafka has turned into an entire ecosystem, right? And because they have the Kafka broker itself is there, you can create Kafka topics, you can have partitions, but then on top of it they have streaming applications. You have Kafka streams library, you can run your streaming applications. They also have storage there, because so one is definitely Kafka broker stores your data and you can set retention like forever, so you can store your data forever. That is a different type of application, though. You can't really query anything. But there is also like using stream processing applications, or sorry, libraries. You can store your data in something like a K table, which gives you key value access, because underlying it uses rocksdb for storing the state, and it's so useful
Mm.
for stateful applications. But again, you cannot store everything there, because you need to have more number of Kafka partitions and all that. So there is always bottlenecks, there's always trade-offs.
Yes.
But depending on the
Yes.
type of use case, if it's like a streaming use case where you just want to store data for, let's say, a day or 2 days, and after that the
2 days
data
and
goes away, it's totally possible. You just store it where you want to run the computation. You access the data because you don't have to make network calls, and
right.
then you're done. So but that is a different use case, and I would like to tell the viewers to go look for Martin Klepman's tech talk on using Kafka as a database, and what kind of, so he explains beautifully that what kind of guarantees can be built around Kafka, because Kafka is now an ecosystem, and how it
Right.
can be imagined as a database. So great. And one thing I forgot to mention, or forgot to talk about, you said like SQL databases. And using SQL and using it with relational model is so easy and so intuitive. It comes naturally. And but I think it is
No,
becoming.
I said the other way around. I said no sequel comes naturally, no sequel is more intuitive, but it's just that we have been thinking in sequel way since a very long time. That is why it comes a little more, naturally to us, that okay, thinking sequel is like we have been doing since, so it's hard to change now.
Yeah. I think the point I was trying to make was from the query side. So we are so
Mhm.
used to write SQL queries to get the data. uh,
Yeah.
so from the user's perspective, or let's say even from the developer's perspective, right, querying data has always been SQL. So that comes kind of like easier manner to us. And the world is again moving back to SQL. So if you take examples of the NoSQL databases as well, right? So for example, Cassandra has a language called CQL, which is not entirely SQL. They don't use the same. It's not compatible for Postgres or MySQL, for example. But they want to give the developers and users of the database an access to SQL like interface.
People like,
For example,
yeah,
the CQL is there, and Kafka also has KSQL, which is you write some SQL queries, it will create some Kafka stream application in the back and give you
even
some data. Pinot
even
has
NoSQL gives you,
PQL or
yeah,
something like that. So
PQ.
I think world is moving back to SQL, and I think that is the reason. But let's see how it evolves.
It is not moving back to SQL. I'll beg to differ there. It's just that since we have been learning SQL, and we have been, it's like if you talk about DBs, at least 30, 40 years back down the line, and SQL came in first, and there were no SQL flavors which did not get that kind of acceptance and popularity. Only with the advent of e-commerce, we started having those kind of fixed query patterns, and then thinking in NoSQL way became a little more intuitive and popular. But before that, like, it's a long time that we have been thinking SQL. So what is happening is this new solutions or new offerings or no SQL flavors are trying to get into the SQL, whoever is used to SQL, to give them a chance to try these new offerings. They're trying to make something so that they are already accustomed to SQL. They can move a step further, and they can take advantage of these offerings. They are not moving back to SQL. They are just trying to connect to more and more customers or more and more people, so that they can take advantage of the offerings or solutions available in the market. That is my perspective again, and a personal one,
Yeah,
not
absolutely. I mean,
on behalf of any, yeah,
yeah, yeah,
organization.
absolutely. I mean, whatever we have, uh, done for many years, it becomes like a habit, and people want more
Absolutely.
acceptance there. So I think these
Yes.
companies that are trying to provide these SQL interfaces are trying to do that, so people can use their technologies without this friction of learning a new thing or learning a new language, for example. So yes, I think it makes
Absolutely. Kevin,
sense.
I would like to add. I would like to add. I would actually. You are saying it makes sense, but I actually want to ask you something. So, what is the first advent of technology that happened in your life? Like, first time you saw the computer, first time you operated a mouse. When did it happen? What kind of OS did you use?
uh, I think I used a Windows 95, if I remember correctly.
Okay.
That was my
Okay.
big brother's computer, and I was just playing some kind of card game or something. So that was my first experience. um,
Okay.
yeah, that's what I remember. How about you?
So were you in awe of Windows? I was pretty young. I was in fourth standard when I first, started using my email
Okay.
ID. That is why
Yeah.
my Hotmail is also, so fun, such a funny
Yeah.
name, which I still use. But yeah, so my question is, did you fell in love with? You were in awe, and did you really like Windows over Linux till date? I mean, just giving
uh,
an example, it could be.
yeah. So Yeah, I mean, ease of use was definitely Windows, and when I became like a developer, when I started knowing more about how these things work, I liked Linux better as compared to Windows. So that is definitely a change of perspective for me that happened.
Right, right. But it took some time. So
It
that
took
is
some
what
time.
I'm trying to put across, that first time when we come into, close contact of anything, and that like first experience, that first love, oh my god, oh my god, this game, oh my god, I if I do this, this mouse moves. That first experience is like your first time, and then you actually get used to that, and then when you go out, find different options, different solutions, different competitors or different things which are there at par or doing better, then you try to move. That's a conscious decision,
Hmm.
but the subconscious, and that is where, a lot of key decision makers in senior roles, they might have, used a lot of SQL when they were like us, or their developer roles, or
Yeah.
staff roles, or whatever. Before becoming those key decision makers, maybe they used a lot of SQL or lots of Windows, so
Hmm.
they will make similar decisions, tend to.
Yeah.
Subconscious will definitely, but yes, if you make an informed choice, definitely you will do justice, and I mean, you will do justice to the domain you are trying to solve, or you are trying to give solutions out. But that is the only reason to connect better with such audience who are already in love with SQL. Maybe these offerings are trying to make drivers, and offer languages, even MongoDB does, so that
Yeah.
you
Yeah.
can
Yeah.
use
Absolutely.
SQL to still deal with us. Yeah,
Absolutely. And at the end, as you rightly said, that it's about adoption of any technology. If no one is going to adopt it, it's not going to work. So people try to
yeah,
reach out to people in their own languages, right? And I
right,
was talking to
right.
Jim Walker from Cockroach DB. He's also a developer advocate, and he was telling me that SQL is like the business people language, right? People who want to generate some reports, they are so used to
Right.
writing SQL queries, getting those reports,
Yes,
and it's not
yes,
just that databases are for developers, because some things are also directly used by business people. So yes, I think that
yes.
makes sense, and I think only time will tell where we reach with all these databases. uh,
I
but
think
yeah, let's see.
I think polyglot is something which I really advocate. Again, my
Yeah.
personal opinion, because as you said, a lot of trade-offs and a lot of sweet spots in system design or solving the actual problems at hand. When we were talking about cold start as well, so uh, the, I don't think one particular offering can solve everything out there.
Yeah.
So
Yeah.
it definitely, even when we talk about my current company, it's not one product, it's a lot of products in then DB as a service, which is there to solve a
Yeah.
lot of problems. But then I'm not saying that one particular offering can solve all the problems, because the other domains or other problems which we might not have thought of,
Yeah.
we'll still have to work upon a few things to get those solutions in house. So these kind of cases could also occur. So that is why I say polyglot is my go to thing, that okay, what kind of problem you want to solve and what kind of trade-offs you can live with will define which kind of database you want to use, or which kind of uh, product or company you want to go to for that kind of database. Because if you
Absolutely.
talk
I
about
think,
document stores, there are multiple options for them as well, right?
yeah, yeah.
Yeah,
That
yeah,
that makes sense.
yeah,
I think polyglot is so I have, at least in my experience, I have seen polyglot persistence as a thing, because mainly I've worked in larger organizations that have some good amount of money. They are mature organizations, so they can afford all these polyglot
same
persistence
here,
and optimize for
same here,
certain
same here.
things. But I would like to put
Right.
a disclaimer, like for startups,
Mm,
for people who don't want to spend a lot of money, start with, I
mm,
think, as you also said, start with the monolith, right? You don't have to
mm,
spend, you don't have to solve the problems you don't have. Start with a simple
right.
MySQL or a Postgres database, work with it,
Yeah.
get the features out, test with your customers, earn some money, make more money, earn more revenue, and then split that use case and solve the problems.
We should not go for any random decision. But even if I am a startup, I would like to reiterate on that point that okay, start with a monolith and start with a simple data storage, be it SQL or
Yeah,
no SQL, because no SQL solutions are also cheap. It depends if your platform or your startup is query driven or not, as you were saying, like view driven. If there are only a fixed number of views or queries which will be fired on your platform, then maybe you can consider a NoSQL solution, which will come handy and cheaper compared to a SQL solution. So that is where I'm coming from. Monolith plus SQL or NoSQL, depending upon what kind of problem you're solving. If your
yeah,
system is a lot query driven, like you have definitive set of queries, plus your schema keeps changing or not, that kind of thing, you can take the decision on the SQL NoSQL, because I think NoSQL
yeah,
solutions are quite cheaper as compared to SQL solutions, as far as I have done my research. So that
absolutely.
is where. So, but yeah, for the startups, monolith plus whatever they want to, making a calculated or conscious decision
Yeah.
on the SQL and NoSQL part.
After a startup, monolith makes sense, and do what your organization can support. So it can be MySQL, and as you said, it can be a NoSQL solution, right? It depends on what kind of developers you have. If you have your development team who has experience with Cassandra or MongoDB, go for it, right? If that solves your problem. So I wanted to say that, MySQL as an example, but yes, thanks for
Mm.
putting that out, that it can be a NoSQL
Yeah, yeah.
solution as well, because NoSQL has so much support these days. It is also cost effective. So great
Yes,
point
it
there.
is cost.
Yeah, yeah, cool. Uh, I think we have covered a lot about how these decisions are made, how what kind of trade-offs we wanted to look at when we choose a certain database. Let's talk a bit on how cap theorem applies, right? Because whenever we talk about databases, whenever we talk about distributed system, cap is a thing that needs to be there, at least in like conceptually. How do we understand? So
Yes.
what do you think, when we make those decisions, how would cap help us make those decisions in a better manner?
When we talk about any application, again, you go back to the functional requirements, then the non-functional requirements comes in, and you say, hey, what is the go-to thing for me? Is it the availability or is it the consistency? How I explain it is, do you want your user to be blocked until everything is become has become consistent?
Hmm.
But in that case, in some of the domains, user might be blocked infinitely, because there might be data coming in
Yeah,
and you just are making the system consistent. So mostly it's like a AP kind of system which we look at, because any which ways distributed system has to be partition tolerant, because
yeah,
there could be something and you need to have a graceful exit for the user. At least they shouldn't be hanging. So, and when we talk about consistency, even SQL will not be consistent until unless it is being replicated synchronizing in a synchronized manner. If it is replicated in an asynchronized fashion, eh, there could be a consistency, eventual consistency in SQL as well. So when people talk about eventual consistency in NoSQL, no, it is not related to NoSQL.
yeah,
It is like any database, if they are going to replicate in an asynchronized manner, uh, then it is going to be eventually consistent. And eventually consistency is like, you will never be consistent, because there will be some kind of input coming. If it's an
yeah,
active system, there will be some kind of input will be coming. And that is why I think, be it any DB, there might be a little gap between the data, because if you are going to make your system fault tolerant, you will have replication, be it PSS, or you go with P and then four secondary nodes, whatever. There are, I think, three famous models are PSS, and then P4S, and then P6S, because there could be, the secondary nodes have to be even according to, I think, the Raft
hmm,
algorithm. So these three, whatever you choose, if you are going to replicate amongst them, be it your execution log or operational log or whatever, or the priority, whatever you are using to choose the another secondary also if something goes down, or even if you are doing a scheduled backup and then depending on the your log to come your, there could be a chance wherein some data might be missed, or the system will be eventually consistent. It doesn't matter it is SQL or no
Hmm.
SQL. So I feel even if you choose consistency over, I mean, it's just that it will hit your, like if you have that kind of SLA, like for example, when I think of banking systems, so we are
Hmm.
ready to it. It will just keep buffering, keep loading, and we are ready to it. So we have that kind of SLA, or we have that kind of expectation as a user. Okay, it will take some time. I should
Yeah.
not refresh it. I will wait here. So because it is, I think it will go and I mean it will replicate everything in a synchronized fashion. That is the consistency I can think of. Otherwise all other systems I have seen um, a lot of gaps, I mean in the consistency, because sometimes I'll see different number of likes. I'm
Yeah.
just giving a very vague example. Sometimes I'll see different number of likes or actions. So but does that
Yeah.
matter? Does that matter? Even if it is a few likes here or there, a few reactions here or there, or my edited post, I mean if I'm trying to edit something and I see it a little bit later, or you see it a little bit later,
Mm.
it doesn't matter that much to me. So that is why I think AP is the go-to thing. But yes, if it's like a banking thing or something, let's say if I have a joint account with someone and I am doing some shopping and they are in a different time zone and they are getting alerts and they are not able to reach me, and then they are, oh my god, what is happening? So that is the kind of thing. I mean, banks that bank might be having a lot of mails or calls because of these kind of issues. So their consistency definitely matters. Again, domain
Yeah.
driven decision. Otherwise, I think mostly commonly in the problems we are solving
Yeah.
these days, it's like AP paradigm which we
Absolutely.
would go
Yeah.
to.
I think you raised some great points there.
Yeah.
So like it again depends on the what kind of customer impact it will have. For example, if a customer sees an incorrect balance, it's a huge
Mhm.
impact. Like they will really get scared, like what
Mhm.
is happening, where is my money, or how do I have more
Yeah.
money, or something like that. But if I see on Facebook or let's say
Yes,
LinkedIn
yes.
likes, if I see like if there are 32 likes, I see 29, no one is going to bother about it, right?
Yeah.
And it's going to be corrected eventually. So and
Yes.
for example, I think YouTube and all, they
Right.
have so many live updates coming in. They can't really have like an accurate count.
Right.
There needs to be some approximation or some eventual consistency there. So
Yes.
yes, it depends on the use case and the
Yeah.
customer impact. And but yeah, modeling or taking those decisions, or at least understanding how cap theorem applies to a certain technology, uh, adds a lot of value, because
Mhm.
you can then translate it to the customer impact that you're going to have if things go bad. uh, so yes, it makes sense. And I
Right.
think some
Right.
of the databases also provide this tunable consistency model where you can use it as a AP database or a CP database. You can do what you want, but there are of course trade-offs. So yes, I think that adds a lot of value if you
Right.
understand the cap theorem in your perspective. uh, Great.
Absolutely.
Any so I think we have talked about so many different things, and uh, so many ideas, so many experiences. Let's summarize it a bit, right? So if you have to summarize whatever learnings or whatever experiences or insights we have shared in this episode, how will you summarize that?
Mhm. Mhm. Okay, I think that we talked about systems on the whole, and then we talked about DBs, where DBs come in, and I feel that DBs are something which are there to support your solutions, whatever applications or
Yeah.
solutions you are going to build in a cheap and cost optimized way, by helping you store your data, giving you a persistent storage, So giving that guarantee to the customer that okay, your data will not be lost. uh, Plus it will help you, it will
Hmm.
let you query that data easily, even if some data is corrupt or encrypted. That could be that should be able so if you are a developer, or it should not be that cumbersome to query. There should be particular drivers. Let's say you should not be uh, forced to change your tech stack just
Yeah.
because you are changing the db. So that also. And then if you have any changes, if I am talking about the developer perspective, again, zero downtime kind of migration, zero downtime time kind of schema changes should be doable. So that again, as a developer, you don't worry much about that. It's not only developer perspective, but also guarantees the SLA promised and
Yeah.
the low latency to the user. So that these kind of things, if the database guarantees, definitely your solutions will be much relevant to the customers, as well as you will earn more revenue and you will not lose on to the competitors. Apart from that, if you have a problem to solve which you are just starting, so maybe you can start with the monolith paradigm rather than jumping onto any other paradigm, like which are like more famous, or because in system design nothing is silver bullet. You said microservices not a silver bullet. Nothing is a silver bullet. And you should only solve out the problem at hand and add more components or complexity when you have that kind of problem. So be it like you if we try to have more components in the system, it will add to complexity, more maintenance, and more problems rather than solving that. So that is where we have to see and take mature decisions as a team or as a company, like what to do. And I think a lot of things are doable by mix and matching solutions, or maybe as I was saying, that we can store audio video in NoSQL flavors or SQL flavors as well, but then it becomes cumbersome or slow. So these kind of trade-offs, or this kind of facts, we have to think about. And then if we want to go for a
Yeah.
SQL or NoSQL flavor, because both are cost effective these days. There's so much competition that I'll not say Postgres is more cost effective, or I would rather say NoSQL is more cost effective in a lot of the. But then you have to decide on the basis of your features which you want to deliver to the customer. Are they there are definitive query patterns which you are only looking for, I mean, to answer some of the query patterns. Then you can maybe go and choose NoSQL, when you
Hmm.
store the data as is and just load it whenever you want to. And if you don't have that kind of query definitive query patterns, maybe you can choose relational, wherein it's more uh, you already have the experience, the dev team already has the experience with the SQL, so maybe SQL is a more go-to solution for them. So that is where I think it depends on the domain, as well as the resources and the team which is
Perfect.
involved, or the company where the decisions have already been taken. So these three four factors, I think, are the important driven factor. And yes, definitely, if developers know the cap theorem and the design principles and have that understanding of domain,
Yeah.
it will make them know their dbs better, and come out with better solutions with lesser performance bottlenecks.
Perfect, perfect. I think you did not miss a single point that we discussed, and I was just, trying to remember if there was something that you missed, but I think you really nicely just summarized whatever we discussed, and it makes a lot of sense. So, thanks for the summary, and thanks for the insightful discussion that we had today. I really enjoyed this discussion on databases, and also some of the great points that you mentioned based on your experience, that start with the customer, solve the right use case, don't solve a problem that you don't have, and take decisions based on different parameters that you have. It's like in real world, it's not like hypothetical, it's all realistic that you have to solve. So makes sense, and thanks a lot.
So it was really fun to talk to you today, and looking forward to more such podcasts. And all
Absolutely,
the best for
absolutely.
your upcoming months as well.
Thank you so much. Thank you.